Yes, just now here actually figure A shows an ideal spring attached to rigid support here, and to the other end we have connected a mass M placed in equilibrium condition here. The spring just taut. There is no further natural length. Now just remain here. Now if we stretch it away from this position, then due to elongation the length it start applying spring force towards opposite to the direction of displacement. Here mg weight act downward, normal action act upward. Since there is no acceleration in vertical motion direction, there is no acceleration direction, vertical direction. So in vertical direction body in equilibrium. Mg only the net force is spring constant F equal to minus kx. Or if I have shown this, if we press this, then it will try to expand, and the force will be again opposite to displacement. हाँ भाई, अब यहाँ तो फोर्स है, यहाँ तो इधर होगा. Always equilibrium position, force act always. So here mg is equal to n, no net force in upward vertical direction, but net restoring force F is equal to minus kx, where k is spring constant, x is the increasing length. If this is the force F acting on mass m due to spring, this force F is acting on mass m due to spring. Weight is balanced by normal action of the floor of the surface. If alpha is the acceleration, then F is equal to m alpha is equal to minus kx, or alpha is equal to minus k upon m into x. So k by m constant, since k by m is a constant value, so acceleration proportional displacement, hence acceleration proportional to displacement. And has direction. Towards equilibrium position. So motion is simple harmonic, hence motion is simple harmonic. इसकी motion of mass m. Comparing equation 1 with the equation of SSM minus omega square y, we get here again omega square equal to k by m and t equal to 2 pi upon omega, so again m upon k. So whether spring is suspended in vertical direction or placed on horizontal, the time period same, k by under root. Okay. Omega is called angular frequency, omega under root k by m. So this is called natural angular frequency. Now actually I want to tell something about k, spring constant. It is elastic property of spring. We have learnt Young's modulus. तो वैल्यू ऑफ k जो है ना, हमारा ये स्प्रिंग है, what are those factors on which value of k depend? I told you material means Young's modulus, elasticity of material. We have learnt the Young's modulus is equal to F into L upon A into small l the increased length. Or from here F is equal to YA upon L into small l. Comparing with F is equal to Kx. This is elongation. So here K is equal to YA upon L. A is not this area. Area of the area of this wire, जिसका ये स्प्रिंग बनेगा. Have you got my point? Capital L, sorry. So larger the length of spring, smaller the value of K. Please note it. Longer L of spring, thicker the wire, larger the value of K, greater the Young's modulus. This is an approximate idea. This is not exactly true. So this way spring constant. Actually once one of my friend asked a question, when a spring of constant K is cut, this is the spring. If the spring cut into two equal parts, then what is the spring constant of each part? What is the spring constant of each part? So till length become half, so K become K dash, now spring 2K. I asked him, do you know the explanation? कि no ये होता है. So this situation actually, teacher is also a learner. He has learned from somewhere. कि okay, university को ये हिसाब लगा हमने कि longer the length, smaller the L मान लिया. हम कुछ चीजें एज्यूम करके आगे बढ़ते हैं. Please at this stage try to understand the basic facts. Otherwise you will be trapped somewhere. If you are a thinker, you think what you are learning, then there will be a lot of trouble for you. Now I come to combination of springs. Actually खूब सारा प्रॉब्लम आता है इस पे. कॉम्बिनेशन ऑफ स्प्रिंग्स. Suppose here one spring constant K1 welded together with another spring, a constant K2, weight and be suspended. So K1, K2. Please write small k like this. One situation. Here other situation horizontally भी हो सकता है सर. जरूरी कैसी हो? This one K and here other K2 and it is mass M. K1, K2. So when we put this, so here mg is a force applied downward equal to F, ये F हो गया है. तो the spring will get is in figure 1. दोनों, ये figure A, ये figure B, figure 1 का. Now figure 2 is like this. Here the spring and mass is in between, and here it is also like this. or you can be here given like this. The two springs are there, mass in between, have a K1, K2. K1, K2 mass here. Or you can be given like this. Two springs are connected and same mass am attached. K1, K2. K1, K2. ये फिगर 2, ए पार्ट बी पार्ट, और इसके लिए क्या होगा, इसके लिए फिगर बी, ये फिगर ए, ये बी. तो हियर टू स्प्रिंग्स आर कनेक्टेड लाइक दिस टू सेम मास. K1, K2. Actually, I come in contact with different students and I read different books. I am sorry to say, every one person want to become author. I could not be till now. I am not so intelligent. Actually, I understand the book, read the book, really understand the book, and then teach what I got. So they tell here कि we are here try to find total spring. No, total नहीं कहेंगे आप यहाँ. Equivalent spring constant, equivalent. हमारा aim है यहाँ पर to find equivalent spring constant. In class 10 you have determined series parallel resistance R1 R2. सीरीज में के R1 प्लस R2 टोटल रेजिस्टेंस नहीं, वो इक्विवेलेंट है वो. इन प्लेस ऑफ R1 R2 वी वांट टू कनेक्ट ए कंडक्टर विच कैन टेक सेम करंट फ्रॉम सेम सप्लाई. तो इक्विवेलेंट व्हाट इज इक्विवेलेंट का मीनिंग, व्हाट इज इक्विवेलेंट? इफ सम पर्सन कैन डू द सेम वर्क एज आई कैन डू, then he is equivalent to me in terms of that work done. He may be elder than me, younger than me, but if he can do the same work, he is equivalent to me. Now, if here x1 and x2 are the elongation, तो x1 plus x2 जो है मान लो टोटल elongation होगा in figure 1. In figure 1 और F1 इक्वल टू माइनस K1 x1 और F2 इक्वल टू माइनस K2 x2 आर द टोटल फोर्स. और वो एक ही है जो जितने फोर्स से खींच रहे उससे ये होगा, सेम होगा वो. और यह F1 इक्वल टू F2 इक्वल टू F ही है, बट नाउ वी मल्टीप्लाई दिस बाय K1 K2 दिस बाय K1. तो K2 F1 प्लस K1 F2 इक्वल टू माइनस K1 K2 x1 मल्टीप्लाइंग, सॉरी मैंने पहले जोड़ दिया, सॉरी, मल्टीप्लाई K2 तो F2 K1, सॉरी यार, K2 F1 इक्वल टू माइनस K1 K2 x1. Just for simplicity, here by K1 F2 is equal to minus K1 K2 x2. Adding these two equations, we will get, देखो F1 इक्वल टू F2 इक्वल टू F, So this is F into K1 plus K2 minus K1 K2 common x1 plus x2 or F is equal to minus K1 K2 upon K1 plus K2 into x1 plus x2 is equal to x. So we get the restoring force in terms of K1 K2. Comparing equivalent, if we use single spring here, which get elongated by x when applying force F. So then F is equal to I write minus Kx. Comparing these two equations, we get equivalent spring constant. Equivalent spring constant क्या मिलेगा? K equal to K1 K2 upon K1 plus K2 और 1 upon K is equal to K1 plus K2 upon K1 K2. So it will become 1 upon K equal to 1 upon K1 plus 1 upon K2. One upon K is equal to, why I have derived like this? Suppose we connect more than two springs. अगर हमने more than two springs कर दिए तो equivalent will be 1 upon K equal to 1 upon K1 plus 1 upon K2 plus 1 upon K3 and so on. हाँ भाई, sorry ये figure मिट गई भाई. Figure 2 was like this. Here this is. हाँ भाई. Sorry. K1 K2. तो इन फिगर 2 क्या होगा भाई यहाँ पर ये दोनों तरफ मास एंड हियर तब फिगर 2 और ये 3 दे आर in the same manner actually. If we elongate it by x, it will get compressed by x. So it will get elongated the force this way and compressed this way. So similarly here both springs are equally elongated or equally compressed. So in figure 2 and 3, the force due to each spring in the same direction, and we can write that is equal to minus K1 plus K2 by x into x. Same here. If you elongate it, so it will get compressed. Force देगा इसका भी सही. Similarly here. So if K is the equivalent, then F is equal to minus Kx. So here K is equal to K1 plus K2. In these two, both figure, the equivalent is sum of the spring constant of each. So in coming video, I will be telling you some questions based on spring constant. I hope you will like this topic and please learn, this is important. In many competitive exam, a variety of question is based on spring constant. Thing is simple, but they turn the question in such a manner that we forget how to apply. So please learn it and do a good practice of numericals. And someone, actually I told you in last video, gave me the comment, great. Actually I solved many numerical in one video depending on simple R motion. तो अच्छे लगे होंगे उनको। थैंक यू।